today we are going to be finding sine, cosine, and tangent for angles that are not an angle that are on our unit circle. Like, what if I wanted to find the sine of 75 degrees? Is 75 degrees an angle off of the unit circle? One of our special angles? No. So what we're going to do is we are going to use two of our special angles, and we're either going to add them or subtract them to find sine, cosine, and tangent for values that are not on the unit circle. So if I wanted 75 degrees, what two angles do we know that we could use to add to 75 degrees? 45 degrees. Yeah, we could do 45 degrees plus 30 degrees. So that's what we're going to do today, and with the use of these 6 formulas, we can find sine, cosine, and tangent of other angles that are not included on our unit circle. So looking at problem number 1. Number 1, we want to find the sine of 255 degrees. Is that one of our unit circle values? No. But I can use two angles to add up to 255 degrees that are off of the unit circle. So what two angles off of our unit circle could we use to add up to 255 degrees? Yeah, we could use 210 degrees and 45 degrees. Or we could have done 225 degrees and 30 degrees. So there's not just one option. There's multiple ways you could choose to add two angles. So it doesn't matter which pair you choose or even which order if you're adding. In the end, your answer will be equivalent. Okay, so we need to use that first formula on your handout. We are doing the sine of A plus B. And that formula says that for the sine of angle A plus angle B, we need to do sine of A times cosine of B. So this would be sine of 210 degrees times cosine of 45 degrees plus, then we need to have cosine of A times sine of B. So cosine of 210 degrees, sine of 45 degrees. Now, all of these are in reference to our special angles. So sine of 210 degrees. First of all, 210 degrees terminates in which quadrant? Quadrant 3. In quadrant 3, should the sign be positive or negative? Negative. And what is the reference angle for 210 degrees? 30. And what's the sine of 30? 1/2. So sine of 210 degrees is negative 1/2. Cosine of 45 degrees. What's the cosine of 45 degrees? Square root of 2 over 2. Bring down the plus sign. Cosine of 210 degrees. Again, 210 degrees is in quadrant 3. In quadrant 3, should the cosine be positive or negative? Negative. And what is the reference angle we already said was 30. So what is the cosine of 30 degrees? Square root of 3 over 2. And the sine of 45 degrees? Square root of 2 over 2. Square root of 2 over 2. Now we need to simplify, so we need to multiply those two fractions. So for this first one, this would be negative square root of 2 over 4 plus, now over here we have two radicals that we need to multiply, and you need to remember from Algebra 1, when you're multiplying two radicals, if I have square root of A times square root of B, you multiply the radicand. So A times B gives me square root of AB. So multiply the inside. So this is going to be negative, so instead of the plus sign, I'm going to change this to a minus. And square root of 3 times square root of 2 would be square root of 6. 3 times 2 is 6. And in the denominator, 2 times 2 is 4. Now we have a common denominator, so we can go ahead and subtract these. So we keep the 4. And in the numerator, it's negative square root of 2 minus square root of 6. Final answer. Now, if you chose a different angle pair, your answer might have looked like negative square root of 6 minus square root of 2 over 4. But those answers are equivalent. So if you chose a different pair of angles, then possibly the numerator might be switched around, but that answer is still equivalent. Okay, next one, problem number 2. We want the cosine of negative 195 degrees. So we can either add two angles to get negative 195 degrees, or we can subtract two angles to get negative 195 degrees. Now, if it's negative, we probably need to subtract. And what two angles can we subtract to get negative 195 degrees?
Negative 150 and negative 45.
Yeah, we could do negative 150 degrees minus 45 degrees. That would add to negative 195 degrees. That would work. Or what about if I did 225 degrees? Oops, no, I don't want 225 first. I want this to be negative. What would this number have to be? 30. So there would be another possible option. So you and somebody else may not use the same angle pair, so that's fine. Your answers, if worked correctly, will be equivalent. So we are doing cosine of A minus B. So you need to be careful because what is angle A? Negative 150 degrees. What is angle B?
Negative 45.
It's just 45 degrees. So it's just the number behind the minus. Okay, so now, using the formula, we have cosine of A minus B. So that is that fourth formula, so we need to do cosine of A times cosine of B. So this would be cosine, what do I put for A? Negative 150 degrees. Cosine of angle B is 45 degrees. And then we'll have a plus sign in the middle. So we need to have sine of angle A, sine of angle B. So that would be sine of negative 150 degrees, sine of 45 degrees. Now, negative 150 degrees, if your angle is negative, that means we are rotating counterclockwise. So starting in standard position, here would be negative 90 degrees. So negative 150 degrees terminates in which quadrant? Yeah, right here in quadrant 3. So in quadrant 3, would the cosine be positive or negative? Negative. And what's the reference angle for 150? 30. And what's the cosine of 30? Square root of 3 over 2. So negative square root of 3 over 2. And what's the cosine of 45 degrees? Square root of 2 over 2. We'll have a plus sign. Sine of negative 150 degrees. Again, negative 150 degrees terminates in quadrant 3. So in quadrant 3, would the sign be positive or negative?
Negative.
Negative. We said the reference angle was 30 degrees. So what's the sign for 30 degrees? 1/2. So negative 1/2. And what's the sign of 45 degrees?
Square root of 2 is 2.
Square root of 2 over 2. Simplifying, we need to multiply these fractions. So this would be negative square root of 6 over 4. And instead of a plus, instead of adding a negative, just change it to subtraction. And this would be square root of 2 over 4. We have a common denominator, so keep the denominator the same, and put the numerators together. So this would be negative square root of 6 minus square root of 2. Now again, if you chose a different angle pair, it's possible that your answer would be negative square root of 2 minus square root of 6 over 4, but those two answers are equal. Next one, problem 3. Number 3, we need tangent of 345 degrees. So we need two angles that add up to 345 degrees. And what can we use? 345. Or you could have done 315 degrees and 30 degrees. You'll get the same answer in the end. So we are doing tangent of angle A plus angle B. So the formula for tangent of A plus B is tangent of A plus tangent of B. So that would be tangent of 300 degrees plus tangent of 45 degrees divided by 1 minus tangent of 300 degrees times tangent of 45 degrees. Tangent of 300 degrees. What's the reference angle for 300 degrees? 60. So if I do sine over cosine, what's the sine of 60? Root of 3 over 2, or what's the cosine of 60? 1/2. And 300 degrees terminates in which quadrant? 4. So in quadrant 4, would tangent be positive or negative? Negative. And square root of 3 over 2 over 1/2 simplifies to? Yeah, so this would be negative square root of 3. Then we'll have a plus sign. And what's the tangent of 45? 1. And in the denominator we'll have 1 minus, and then we need to multiply those two tangent values, so we need to multiply negative square root of 3 times positive 1. Now when we write our answers, we normally don't put the radical out front, we put the radical in the back. So I'm going to rearrange that numerator so the radical is at the back. So make sure the square root stays negative and the 1 stays positive. Now in the denominator, drop down the 1. Negative times a negative becomes positive, and square root of 3 times 1 is square root of 3. Now technically, you should leave a radical in the denominator. We should rationalize that, but to rationalize that, we would have to multiply by what's called conjugate, which would be 1 minus square root of 3, and I feel like we've done enough work already. So just make sure you put the radicals at the back. You won't have to rationalize these. Okay, next page, number 5. Now these actually will go pretty quick, and these will look really similar to some of the formulas. Did I skip one?
Mm-hmm.
I did, okay, so let's go back. Okay, number 4. It has to be negative, so we'll need to subtract. So this would be tangent, and what can we subtract to get negative 285?
Negative 240 minus 45.
Negative 240 degrees minus 45 degrees. So if it ends in a 5, you probably have to have a 45 degrees somewhere. So this is angle A minus angle B. So this would be tangent of angle A, not instead of A, what should I put? Negative 240 degrees. I'm going to put that in parentheses so it doesn't look like we're subtracting 240 degrees. And we need to subtract tangent of B. And what is angle B? 45 degrees. And then in the denominator we will have 1 plus tangent of negative 240 degrees times tangent of 45 degrees. Okay, negative 240 degrees terminates in which quadrant?
Third.
Quadrant 2. So here would be negative 90, negative 180, so negative 240 would be right here in quadrant 2. So in quadrant 2, would the tangent be positive or negative? Negative. And what's the reference angle there? 60. So if I did sine over cosine, what's the sine of 60 degrees? Did we just do that? That was 300, and what was the reference angle over here? 60, so we got square root of 3, so this one is also negative square root of 3. So this would have been square root of 3 over 2 over 1/2. And subtract the tangent of 45 degrees, and what's the tangent of 45 degrees?
Square root of 2 over 2.
Square root of 2 over 2 over square root of 2 over 2, which would be 1. We'll have 1 plus, then we need to multiply those two values together. Negative square root of 3 times 1. Now again, make sure the radical is of the back. So make sure it's negative 1 minus square root of 3. And in the denominator, bring down the 1. And negative square root of 3 times 1 is negative square root of 3. And again, we're not going to multiply by the conjugate. We'll just leave it as that, as our combination. Now for the back page. Oh, page 1. So here's page 2. Now, we need to see which formula does this one look like. So notice for number 5, we have cosine of angle A, cosine of angle B, plus sine of angle A times sine of angle B. So which formula does that look like? That looks like cosine of A plus B or A minus B. Notice we have a plus sign right here. So would this be cosine of A plus B or cosine of A minus B? A minus B. So this is cosine of A minus B. What do I put for angle A? 3x. What do I put for B? 2x. And that simplifies, so make sure you simplify completely, and 3x minus 2x is x. So the answer is just cosine of x. Can't do anything with the x. Next one. This is sine of angle A, cosine of angle B, minus cosine of angle A, sine of angle B. Which formula does that one look like? Yes, this would be sine of A minus B. So sine of A minus B. So that would be sine. Instead of A, what do I put? 105 degrees. And for B? 15 degrees. And when I subtract those, what do I get? 90 degrees. Does that simplify? Yes. Think about your unit circle. 90 degrees is up here. And what is that ordered pair? 0, 1. So what is the sine of 90 degrees? 1. So that one does simplify because we didn't have x. This time we have the angle. Next one. Now this one definitely is going to be one of the tangent problems. And this would be tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. So is this the tangent of A plus B, or is it the tangent of A minus B?
A plus B.
A plus B is right. And what do I put for A? 30 degrees. What do I put for B? 15 degrees. 30 plus 15 would be
45?
45 degrees. Can I simplify that?
Indeed.
Yes, what's the tangent of 45 degrees?
1.
1. Okay, back to some of our familiar triangle problems. It says suppose sine of angle A is equal to 4/5, sine of angle B is equal to 5/13, where A is between 0 degrees and 90 degrees, and angle B is between 90 degrees and 180 degrees. Find the value of cosine of A plus B. Now that will be straight off our formula sheet, but before we do that, we need to come over here and draw ourselves a diagram. So they tell us that angle A is between 0 degrees and 90 degrees. So angle A is in quadrant 1. There's angle A. And they told us the sine, and remember way back when, we said that sine was opposite over hypotenuse. So the opposite side, label it as 4. The hypotenuse, label it as 5. And if you know your Pythagorean triples, what is that missing leg?
3.
3. This is a 3, 4, 5. Now angle B, we're told angle B is between 90 degrees and 180 degrees. Here's angle B. And we are also given the sine, which is opposite over hypotenuse. So the opposite side is 5. The hypotenuse is 13, and what would the missing leg be? 12. So this is a 5, 12, 13. Now with these triangles you have to be careful because some of these legs could be negative. So this 12, if it's on the left side of 0 instead of 12, this should be negative 12. So be careful when you're labeling those legs. So if it's on the left side of 0, it needs to be negative. Okay, now that I have my triangles labeled, make sure they're labeled correctly, because if these triangles are not right, then your answer for cosine of A plus B will also not be right. Now, from the formula chart, they asked us for cosine of A plus B, so we need to do cosine of A times cosine of B. And then we will subtract sine of A times sine of B. Now sine of A and sine of B, they gave both of those to us. But for the cosine, we'll have to look at our triangles. So for cosine of angle A, looking at this triangle right here, cosine would be adjacent over hypotenuse. So what's the cosine for angle A? 3/5. And for cosine for angle B, look at this triangle, and what is adjacent over hypotenuse? Negative 12, 13. Minus, sine of A and sine of B were given to us in the problem. They said sine of angle A is 4/5. Sine of angle B is 5/13. Now, everything we are doing today is without a calculator. So on the test Tuesday, this will be on the no calculator part. So, multiply your fractions. Multiply the numerators. 3 times negative 12, negative 36. 5 times 13 is 65. Drop down the minus. 4 times 5 is 20. And 5 times 13 is 65. Keep the common denominator and subtract the numerators. What's negative 36 minus 20?
Negative 56.
Negative 56. Now, if your fraction will simplify, make sure you simplify, but will that fraction simplify? No. So the answer is negative 56 over 65. Okay, number 9, it says, suppose sine of angle A is 3/5 and A is in quadrant 2. The tangent of angle B is negative 12/5 with B in quadrant 4. Find the value for the sine of angle A plus B. So again, diagram it first. Angle A is in quadrant 2. Here's angle A. And they gave us sine, again, which is opposite over hypotenuse. So the opposite side is 3, the hypotenuse is 5, and what is this missing leg? 4, but if it's on the left side of 0, it needs to be negative. Be careful with those legs. And angle B is in quadrant 4. And for angle B, they give us tangent, which is opposite over adjacent. Now, one of those has to be negative. Which side would be the negative side? The opposite side or the adjacent side? Opposite. This is below 0, so that needs to be negative 12 and positive 5. And what's the hypotenuse?
13.
Yeah, this is a 5, 12, 13, and the hypotenuse is always positive. From the formula chart, we need to do sine of A plus B, and that's the top formula, and that is sine of A cosine B plus cosine A sine B. Sine of angle A they gave to us, that was 3/5. Cosine of angle B, now we move to this triangle over here in red. And what's the cosine for angle B? Adjacent over hypotenuse. 5 over 13. Cosine of angle A, so go back to the blue triangle. What is the cosine for angle A?
4/5.
Negative 4/5. And then sine for angle B, go to the red triangle, and what's the sine for angle B? Negative 12, 13. Multiply your fractions. 3 times 5 is 15. 5 times 13 is 65. Now notice we do have the 5 that would cancel. So if I cancel the 5, would I still have a common denominator of 65 to add these fractions? No. So that won't actually be a benefit to cancel out those 5s right there. And negative 4 times negative 12 is positive 48. Keep the common denominator, and what's 15 plus 48? 63. So 63 out of 65. If that fraction would simplify, simplify it down. Okay, on number 10, we're not going to do this one. We're just going to do the tangent. We've already done sine and cosine with these triangle problems. So number 10, it says suppose cosine of angle A is 12/13, where angle A is in quadrant 4, and cosecant of angle B is negative 5/3, where angle B is in quadrant 3. We need to find the tangent of B minus A. So again, draw your diagram first. They said angle A is in quadrant 4. And they gave us cosine, so cosine is adjacent over hypotenuse. So the adjacent side is 12, the hypotenuse is 13, and what is the missing leg?
Negative 5.
Negative 5. Why is it negative?
Because it's going down.
Yeah, it's below the x-axis. And the other triangle, they said angle B is in quadrant 3. And they gave us cosecant, and cosecant is a reciprocal for
Sine.
sine. So sine is opposite over hypotenuse. This would be hypotenuse over opposite. Now, can the hypotenuse be negative? No. So I know the hypotenuse has to be what?
Pository.
Positive 5, and the opposite side would have to be
Negatory.
negative 3. And what about the missing leg? -4. It's on the left side of 0, so it needs to be negative. Now, tangent of B minus A, straight off the form. Actually, do we have a formula for B minus A? No, we have tangent of A minus B. So what I'm going to have to do with my formulas, wherever I see an A, replace it with a B. Wherever you see a B, replace it with an A. So instead of tangent of A, I need to put tangent of B minus, instead of tangent of B, I need to put tangent of A. In the denominator, we're going to have the 1 plus, so I need to multiply these two together, which would be tangent of B times tangent of A. So from the triangle, tangent is opposite over adjacent. So what is the tangent of B? 3/4. What is the tangent of angle A? Opposite over adjacent. Yeah, -5/12. And when we subtract the negative, this will be addition. Then we'll have 1 plus, then we need to multiply those, 3/4 and -5/12. Now in the numerator, in order to add fractions, we'll have to have a common denominator. What's the common denominator between 4 and 12?
12.
12. So in the 3/4, that should be
9/12.
9/12 plus 5/12. And this would be 1 plus, or actually instead of plus, this will be a minus 15 over 48. Go ahead and simplify that numerator, so 9/12 plus 5/12 gives us,
1 and 1/6.
leave it improper, 14/12. And down here, I'm going to make this 1/1, and what would the common denominator be? 48, so I'll make this 48 out of 48 instead of 1. And when you subtract 15 out of 48. Instead of 14/12, that simplifies to what? 7/6. Keep the 48. And what's 48 minus 15? 33. Now again, this is all without a calculator. Now that we are dividing fractions, what do you have to remember to do? Keep, change, flip. So multiply by the reciprocal, and multiply by 48 over 33. 6 and 48 have a common factor of 6, so 6 divided by 6 is 1. 48 divided by 6 is 8. Multiply the numerator, 7 times 8 is 56. 1 times 33 is 33. Just leave it improper. 56 over 33. Now, the last two say to verify. And remember, when you are verifying, you only do operations with one side. So you can either work with the left side and prove that it equals the right side, or work with the right side and prove that it equals the left side. And for this one, it'll be easier to start with the left side because we can use our formulas from today. So starting with the left side, we have cosine of pi plus x. And this is cosine of angle A plus B. Okay, so from the formula chart, cosine of A plus B, we need to do cosine A times cosine B. So that would be cosine of pi times cosine of x. And between the two, we will have a minus. And then we'll have sine of pi times sine of x. Now, does that equal the right side? No. No. So what we're going to have to do is we're going to have to do a little bit of simplifying. So what we're going to do is, if it has an x, like right here, cosine of x, I can't do anything with that. Same thing right here. I can't do anything with the sine of x. But I can find the cosine of pi and the sine of pi. So thinking about our unit circle, where is pi?
Left.
Left side.
Yeah, over here on the left side. And what is that ordered pair?
Zero,
Negative 1, 0.
Negative 1, 0.
Negative 1, 0. So what is the cosine of pi?
Negative 1.
Negative 1 times cosine of x minus what's the sine of pi?
0.
0 times sine of x. What's negative 1 times cosine of x?
Negative cosine x.
Negative cosine of x, and negative times 0 times sine would be
Negative.
0. So the answer is just negative cosine x. So we started with the left side and we proved it equals the right side. Now notice there was work shown here, so make sure you substitute in the values so I can see that you just did this. Okay, number 12, start with the left side, prove that it equals the right side. So I want you to do this one on your own. I want you to show that the sine of theta minus 180 degrees is equal to negative sine of theta. Okay, so we need to do sine of A minus B, where theta is A and 180 degrees is pi. So that second formula would be sine of A cosine of B, so that would be sine of theta cosine of 180 degrees. And between the two, we need to have a minus cosine of A, so that would be cosine of theta sine of 180 degrees. Now, we can't do anything with this theta, but we can find the cosine of 180 degrees and the sine of 180 degrees. So bring down your sine of theta. And what's the cosine of 180 degrees?
Negative 1.
Negative 1 again. Minus cosine of theta, and what is the sine of 180 degrees? 0. What's sine of theta times negative 1? Negative sine of theta. And negative times cosine times 0 would be 0, so it's just negative sine of theta, and we proved that the left side equals the right side.